It should be a little bit shorter than the synchronous class time. I predict it'll take between 35 and 40 minutes. So it's a little bit shorter than our lessons normally are, which is kind of nice. So today's plan is we are going to have a warm up on stuff we previously learned. And then our notes today are in solving quadratic equations by factoring. The things that are due Monday, February 1st by 10 p.m. is Lesson 20 Desmos practice. That's today's. Lesson 21 Desmos practice. That's actually going to be a quizzes practice. That's next class. And then Quest Homework 17. Remember about the grade recovery opportunities. I actually extended mine to the 27th. So the Unit 3 assessment grade recovery, please turn in by tomorrow, not today, by 10 p.m. if you want feedback. And then Unit 4 grade recovery as well. Everyone can do that one. Turn in by tomorrow, not today, 10 p.m. if you want feedback for revisions. The final due date for both of those is Friday at 3:05. Link to both of these are on the Algebra 2 page in Canvas. Everyone that has submitted, I just, during fifth period, went and provided feedback. I emailed if there was feedback, and so hopefully that is helpful as far as revisions go. All right, before we continue any further, are there any questions that you have about anything that I said? All right, so let's go ahead and move on to slide 2 and let's complete the warm-up. So this warm-up is to help with some of the questions on the Unit 4 grade recovery. Remember, everyone can do the Unit 4 grade recovery. If you complete it 100% correctly, showing all your work, your grade will go up by 10% with a max of 100 or to a 60%, whichever is better for you. So the first question is asking you to rewrite the radical using rational exponents. The second question is asking you to simplify the radical completely. When I was grading the assessments, I was very surprised at how many students did not read the directions and simplify the radical when they were asked to write in rational exponents and vice versa. So please go ahead, take the next few minutes, and complete the warm-up as I take attendance. If you have questions as you are going through it, please let me know. Okay, let's see. All right, so everyone should be logged into Desmos. Everybody should be completing the warm-up. So if you haven't gotten started on it, please go ahead. If you ever need the code to join a Desmos, please just let me know and I'm happy to share that in the chat. But you all should be a part of my class. Yes, I see a hand up.
When I open the Desmos, it's not showing me the assignment.
Okay, let me see. Like it's not assigned to you? Okay. Let me open up a new window and I will paste the link to join in the chat. So just give me 1 minute. Is anyone else having that problem?
Miss Denise,
Yes.
I'm confused as if I should put a fraction next to the 32 or just the x.
Yep, great question. Is it underneath the radical?
Yes.
Okay, so what's the exponent on it?
So the x is 7.
The exponent on the 32.
Oh, there's a 1.
So it's understood to be 1.
Okay.
And then the root or the index is 2. So since 32 is under the radical, it does need a rational exponent.
Okay, thank you.
Yep. All right, I went ahead and put the link in the chat. Please let me know if when you click on that, if it still isn't working. All right, so let's go ahead and look. I like how, whoever Isaac Newton is, I really like how you completed question 1. So rewrite the radical using rational exponents. So because the 32 is underneath the radical, okay, it has a power of 1 and a root or an index of 2. So it gets the exponent or the rational exponent of 1/2. Okay, then x has an exponent of 7, power over root, so that's 7/2. Y, again, doesn't have an exponent shown, so it's understood to be 1. So y to the 1/2, and then z to the 10 over 2. I really like how it was simplified to 5. If you can simplify the fraction, simplify the fraction. So number 1, we were rewriting using rational exponents. So great job, whoever Isaac Newton is. Let's look at number 2, because Isaac Newton did a really great job on this one as well. Simplify the radical. So first, broke down into perfect squares times another number. For numbers, perfect squares are anything multiplied by itself, which is 16. For variables, perfect squares have an exponent of 2 since it's square root. So broke it down, simplified, multiplied everything on the outside together, multiplied everything on the inside together. And 4x cubed, z to the 5th, square root 2xy is the correct answer. Okay, please notice how these questions are the exact same expression, but what it's asking you to do is different. So that is why reading the directions is extremely important when you are solving equations. So before we move on, does anyone have any questions on the warm-up? All right, wonderful. Thank you, Isaac Newton, whoever that is today. Wonderful job at your warm-up. All right, so we are going to review what quadratic equations are. We are on slide 3. So a quadratic equation, here I'll go ahead and paste you all to slide 3 to move you along, and then I'll stop restricting. So a quadratic equation is an equation that can be written in standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, meaning there's no imaginary number, and a is greater than 0, so a is not negative. When you are asked to solve quadratic equations, you are asked to find all the possible values for x that make the equation true. So it makes the left side balanced with the right side. Last class, we focused on solving by taking the square root. And this class, we are going to focus on solving by factoring. That is why knowing how to factor is very important. If you still do not know how to factor, I would encourage you to learn rather than picking up your phone and using PhotoMath or MathWay. If you want a refresher on how to factor, I am more than happy to teach you. I remember when I was in school and sitting in math class, and there would be concepts that I didn't know how to do, and I felt like silly for asking because I knew we had learned it months ago. I just didn't know how to do it. And so I never asked for help. So please, 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 even if you think you should know it at this point and you don't, that is okay. I would so much rather you come to me and ask for help than just not know how to do it and continue on. So there's no shame in asking for help. Please ask for help if you need it. I am more than happy to reteach you how to factor if that is what you need. Okay? All right, so let's look at slide 4. So solving quadratic equations by factoring. So I'm thinking of two numbers. When I multiply them together, the result is 0. What can you tell me about the numbers I'm thinking of? So you can go ahead and unmute yourself, thinking of two numbers, or put it into the chat. When I multiply them together, the result is 0. Anyone? Let's see what's in the chat. All right. One of them is 0. Good. 1 and 0. Good. 3 and 0. Great. Yeah, so notice all of those answers are correct, even though they were different. Anything times 0 is always 0. So the zero product rule says if A times B is 0, then either A equals 0 or B equals 0. So let's think of some situations and apply the zero product rule to answer them. So let's move on to slide 5. So type or draw your answer in the box on the right. If 6x equals 0, what must be true? So if 6x equals 0, what must be true?
X equals 0.
X equals 0. Awesome job. Yes. So looking at the responses, I see x equals 0. X equals 0. It would be x equals 0, not 6 equals 0. X equals 0. X equals 0. Yep. Awesome job. Great. All right. Let's move on to slide 6. Type or draw your answer in the box to the right. If x times x plus 2 equals 0, then what could x be? Give you a hint. There are two things that x could be. Can you get both? So I see 0, I see 0, I see -2 and 0, I see 0 and 2, I see -2 and 0, I see 0, yeah, I see 0 and 2 and 0 and -2. So let's look at those three scenarios because I saw three things listed. I saw x equals 2, x equals 0, and x equals -2. So let's see which of these is correct. So let's do the first one, 2. If everywhere I see x, I replace it with 2. So 2 times 2 plus 2 equals 0. So 2 times 4 equals 0. Is that true? Nope. So no, x equals 2 is not a solution. Let's try x equals 0. So everywhere I see x, I put a 0. 0 times 0 plus 2 equals 0. So 0 times 2 is 0. Anything times 0 is 0, so yes, x equals 0 is a solution. Let's look at the last one, negative 2. Negative 2 times negative 2 plus 0 equals 0. Whoops, that should be a 2, shouldn't it? So I have negative 2 times 0 equals 0. So, yep, 0 equals 0, so yes, x equals negative 2 is a solution. So, negative 2 and 0. All right, let's look at slide 7. What about these? Again, there are two possible values. You may want to use some algebra if it's too hard to do this in your head. What values could x be that would make this equation true or balance? All right, let's see what you guys put. I'm looking for values of x. So x equals what? Give you a hint, you do not need to multiply this out. All right, I see 0, I see 2. So let's look at this first one. What value of x would make this first expression 0?
2.
2. Yep. You can either do it just by looking at it. 2 minus 2 is 0. Or you could add 2 to both sides. So let's look at the next one. What value would make the expression 3x plus 4 equal to 0? If you could do it in your head, that's impressive. If you want to use some algebra, that is totally okay too. I'll give you a hint. Solve for x.
Is it 1.3?
Yeah, it is 1.3. What is that as a fraction? Because we want to give exact values, and 1.3 is rounded. So if we're trying to solve for x here, if we subtract 4 from both sides, we have 3x equals negative 4. Then we divide both sides by 3. So x equals negative 4 thirds. And if I check my work here, let's see if that works. 3 times -4/3 plus 4. Whoops. Okay, remember at the top of the screen there's a little calculator that'll pop out, and I can even just copy and paste what I typed right there. Just need to delete the little quotes around it. Cool, that equals 0. So perfect, yep. So x equals 2 and x equals -4/3 are both values for x that make the equation true. Okay, let's look at 2 more scenarios. So let's work backwards this time. If x equals -2, then what could a factor be? So hint, think about working backwards. On the last slide, we saw the factor x - 2 and figured x could equal +2. So what could a factor be if the solution is x - 2? So those who have x equals -2 or x equals +2, those are solutions. What about factors? Eva Tardos, you had it correct. Yep. X plus 2. Notice that the factors are set equal to 0. So in order to move the -2 over, you had to add 2 to both sides. Yep, so it's x plus 2 would be a factor. All right, so let's try one more example. Type or draw your answer in the box to the right. If x equals 3 and x equals 0, what could the 2 factors be? Again, to find factors, we set it equal to 0. So what could the 2 factors be? We are on slide 9. All right, x - 3, great. So there should be no equal sign if it's the factor. So take away the equal sign. Okay, Alice Schaefer, let's not use 2 operations. So if you add a negative, that's the same thing as a negative. All right, notice that the factors do not have equal signs. So, Niels Abel, x - 3 is a factor, if you want to look at my screen, and x - 0. But what is x - 0? What is x - 0? Anyone? Let's see in the chat.
Is it just x?
It is. Yep, it's just x. So we can just take away that 0. So the 2 factors are x - 3 and x. Wonderful. All right. So that all is leading us up to, well, how do we actually solve quadratic equations by factoring? So looking at slide 10, Go ahead and move you all to slide 10. When you solve by factoring, the first thing you want to do is rewrite the equation in standard form, which is ax squared plus bx plus c equals 0. So in this example, we had to subtract 24 from both sides. Then you have to factor completely. After you factor, you use the zero product rule, which means you set each factor equal to 0, then solve for x. And those are your solutions. So let's look at question 11. And let's factor this. So do you guys want to try factoring it first on your own? All right, I'll give you guys 3 minutes to try on your own to 2 o'clock. And then at 2 o'clock, we'll go over it. So we may go to like 2:05, 2:10. So I'll give you guys 3 minutes to try this on your own. You must factor. I'll give you a hint. Multiply first times your last. You need two numbers that multiply to give you negative 30 and add to give you 1. So two numbers that multiply to give you negative 30 and add to give you 1. Those of you who are moving 15 to the right-hand side, don't do that. It needs to be set equal to 0. Let's see. Albert Frank Cox. Close. This adds to give you a positive 1. Sorry, a negative 1. You need it to add to give you a positive 1. So the 6x should be positive and the 5x should be negative if you are Albert Frank Cox. Yeah, perfect. Isaac Newton, let's go ahead and do factor by grouping. That's not correct. You need to multiply your first times your last. Find two numbers that multiply to give you negative 30 and add to give you 1. And then you need to split the middle term. All right, I may just project somebody's answer. Looks like you guys still need another minute or so. Okay, Charles Lewis, you need to split the middle term. You either need to have a 2x somewhere. That's not correct, Charles Lewis. You need to do factor by grouping. Gene Springer, make sure you put a plus sign in between your two expressions. All right, looks like most of you have got it, or you are at a point where you're totally stuck. So let's go ahead and we can go over this together. So the first thing we need to do is split the middle term. So I need two numbers that multiply to give me negative 30, 2 times negative 15, and add to give me 1. Those two numbers are a positive 6 and a negative 5. So I'm going to split my middle term. Instead of writing x, I'm going to write it as 6x minus 5x. The next step is to group together my first two terms, separating them with a plus sign, and group together my last two terms. Then I factor out my greatest common factor. So for my first set of parentheses, my greatest common factor is a 2x. 2x squared divided by 2x is x. 6x divided by 2x is 3. Then I factor out my greatest common factor for my second set of parentheses, which is negative 5. Negative 5x divided by negative 5 is x. Negative 15 divided by negative 5 is a positive 3. Then I factor out my greatest common factor one more time, which is x plus 3. And I'm left with 2x minus 5. Now that I have factored, I'm going to set each factor equal to 0. So x plus 3 equals 0, and 2x minus 5 equals 0. So for my first factor, I subtract 3 from both sides, so x equals negative 3. For my second factor, I'm going to add 5 to both sides. So 2x equals 5. Then divide both sides by 2. So x equals 5 halves. So my solutions are x equals negative 3 and x equals 5 halves. Both of those values, when you substitute it into the original, will balance your equation out and make the left side 0. Questions on this example?
Can you keep it up for a second?
Yep. Notice how important it is to be able to factor. We just have 2 more examples left. They're relatively short, and then we are done. So maybe 210. All right, can you let me know when you have it all down?
I'm good.
Oh yeah, it's a great idea. Take a picture of the screen. Yep. All right. So let's move on to slide 12. So again, solve by factoring. This equation is already completely factored and set equal to 0. So we can go straight to the zero product rule, which is setting each factor equal to 0. Notice this is the exact same factors that we just did in the previous problem, but sometimes the hard part is done for you and the equation is already factored. Let's move on to slide 13 for our last example. So type or draw your answer in the box below, solve by factoring. So steps to factoring: rewrite the equation in standard form, factor completely, both step 1 and step 2 are done. So that means you can move on to step 3, which is use the zero product rule. Set each factor equal to 0 and solve for x. So let's go ahead and do number 9, set each factor equal to 0 and solve for x. Remember that if you click on the calculator at the top of your screen, a scientific calculator will pop up, which is very helpful for your calculations. And we usually write answers as improper fractions, not as mixed numbers. So you can leave it as 17 over 5 instead of converting it to a mixed number. Yeah, so instead of 3 2/5, just leave it as 17 over 5. Yep, wonderful. All right, great job. Okay, most of you have the first factor done. Let's just make sure you have the second. Careful, Charlotte, Scott, whoever that is. You need to add 17 to both sides to cancel out the 17, the negative 17. So that should be a plus 17, not a minus. So Charlotte, Scott. That should be a positive 17, not a negative. Because you have to add 17 to both sides. All right, great. All right, so 17 over 5 and negative 21 are the correct solutions. Okay, are there any questions on how to solve by factoring? Okay, let me just look. All right, looks like most everyone has their answers. Great job. All right, so let's move on to slide 14. You can always go back and finish that slide if you haven't already. So asynchronous time is a great time to get help. So if you're struggling, if you need a little bit of extra explanation, if you felt like I went too fast, please stay on and I am more than happy to help you. Don't forget the things that are due on Monday. Also, don't forget the grade recovery opportunities. So unless you have questions or if you would like help with anything, you are free to log off or you are free to stay. That is totally up to you.